Thank you so much for that introduction, and I'd also like just to give a big thank you to AFMA for allowing me the opportunity to present more my master's topic today. So today I'll be chatting to you very briefly about my MSc topic, which is titled The Determination of Acid Binding Capacity of Various Limestones and the Subsequent Impact on the Gastrointestinal Tract pH, as well as calcium and phosphorus digestibility in the presence and absence of phytase. So let's get straight into it. What is acid binding capacity? Now, this is defined as the amount of 0.1 normality hydrochloric acid solution that is needed to bring 1 kilogram of a substance to a pH of 3 or 4. So then a substance with a high acid binding capacity value requires a large amount of acid in order to bring it down to that pH. And then I want to touch on why we feel it's important, starting with that of enzymatic activity and protein degradation. So as we can see by the graph behind me, the conversion of pepsinogen to pepsin has a clearly demarked pH optimum of around 2 to 3. And we can see that when we move out of this pH optimum, that the peptide conversion and peptide activity drastically declines. Now, this becomes an even further complicated effect when we remember that our younger broilers have an underdeveloped gastrointestinal tract system, and they lack the ability to secrete adequate amounts of hydrochloric acid, meaning that we come into a situation where the proximal gastrointestinal tract may not be in the specific pH for optimum protein degradation to occur and optimum peptide conversion. Now, this was confirmed in Fenter 2019, where it was seen that if you consider the acid binding capacity in dietary formulations, you actually support optimal crude protein digestibility. And this was seen on both day 7 and day 21. Now, this actually translated to an increase in performance on day 21 of both body weight and feed conversion ratio for the broilers that were fed diets of a low acid binding capacity. Furthermore, it's also important when we consider our gut health, and this is actually because of the reduced protein digestion, which allows an increased amount of undigested protein in the hindgut, which allows for fermentation, as well as a substrate for pathogenic bacteria to proliferate. And I think it's quite interesting that today multiple speakers have touched on this topic. So therefore, acid binding capacity is not important only for gut health, but also that of performance. When we look at the acid binding capacity of various feed ingredients throughout different authors, they've come to the pretty concise conclusion that limestone by far has the highest acid binding capacity value. But when we look at the actual absolute values between authors, we can see that there is a large amount of variation. And this is using the same methodology, as well as limestones that are all less than 1,400 microns. But this shouldn't be so surprising to us when we remember that limestone is an incredibly variable feed ingredient. It shows variation in its particle size, calcium content, and solubility rate, just to name a few. This was very well illustrated in a recent study by Golani et al. In 2022 that investigated 640 different limestones globally and found and reported the above values, which just further highlights the extent of variability in limestone that we're including in our broiler diet formulations. Now, this variability in these characteristics becomes a particular concern when we consider how it affects both calcium and phosphorus digestibility, which has been reported by numerous authors. In particular, the particle size and the rate of solubility have been seen to be key factors quantifying differences in calcium digestibility. The same effect has also been seen in phosphorus digestibility, where phytase efficacy has been affected by the different characteristics of the limestones used in the diets. So the list behind me has been clearly proven to all affect calcium and phosphorus digestibility. However, currently no research exists to answer the question, does the acid binding capacity then also affect calcium and phosphorus digestibility in the broiler? Data from Fenter in 2019 investigated this and found a very strong correlation between 5-minute solubility and the calcium content of the limestone, as we can see by this very low p-value and a very strong model with an R-squared of 0.99. Of course, this was done only using 5 samples, so more are needed for the generation of robust data. And then lastly, I do also want to say that our exogenous enzymes such as phytase also exhibit an optimal pH for activity. And we can see this in this graph where if we're going either too low or too high, that we're affecting our phytase efficacy and therefore also our calcium and phosphorus digestibility. So one can hypothesize that if we're feeding a broiler a limestone that has a high acid binding capacity value, we may be shifting the pH of the GIT outside of this range for optimum phytase efficacy. So this brings me to my trial, which is separated into the in vitro and in vivo parts. The in vivo part of this aimed to quantify the relationship between the acid binding capacity of different limestones and their key physical and chemical characteristics. Then for the broiler part of this trial was to evaluate the effect of acid binding capacity of different limestones on the gastrointestinal tract pH, including the gizzard and proventriculus, as well as calcium and phosphorus digestibility. So for the in vitro trial, we measured acid binding capacity at time points 5, 10, 30, 60, 120, and 180 minutes using 0.1 normality hydrochloric acid solution. Both this and the distilled water that was used for the titrations were set in a water bath at 40 degrees Celsius in order to simulate the environment of the avian tract. The pH meter was calibrated weekly in order for accurate readings, and we really attempted to use a wide range of samples from a previously determined limestone database in order for this to be applicable to real life as possible. So this brought us to a total of 38 samples that were determined for their acid binding capacity, which were done in duplicate. The mineral content and the solubility profile of these samples were also done for use of later correlations to be drawn. For the in vivo part, this trial utilized a 5x2 factorial design, utilizing 5 different limestones of different acid binding capacity values, as well as then in the presence and in the absence of phytase. So that brings us to 10. An additional 2 treatments were then included that contained no limestone, both with and without phytase, to bring us to a total of 12 treatments, each of which had 9 replicates, and were done using the Ross 308 male broilers. The birds were reared on large floor pens at the University of Pretoria Large Broiler House facility until day 19, until which they were individually weighed and grouped according to body weight. Thereafter, they were selected in such a manner to ensure minimal body weight variation between the pens and moved to the metabolic house facility. Here, they were fed treatment diets for 36 hours and then sampled on day 21. It's a bit of both, honestly. For sampling, the ileum was then taken as a distance between Meckel's diverticulum and 3 centimeters anterior to the ileocecal junction. Ileum flushing was done into cups onto ice-cold granite slabs in order to prevent any further microbial fermentation from occurring. The samples were then frozen, freeze-dried, and milled before analysis, with pH measurements taken at 3 points in each organ, with the mean of this taken as the final pH value. Data were analyzed in JUMPRO 16.1 using a full factorial model where block was included as a random effect. Where there was no significant interaction reported, the main effects were reported, and when the model was significant, means were separated using a protected Tukey HSD with significance set at less than 0.05. The correlations were analyzed using Pearson correlations. So the preliminary results for the in vivo work. When looking at acid binding capacity, we could see that it was mainly affected by your geometric mean diameter, your particle size of the limestone, as well as solubility, in particular solubility at 5 minutes, which was able to explain 41 to 48% of the variation seen for acid binding capacity at time points 30, 60, 120, and 180 minutes. In a similar manner, the geometric mean diameter of limestone was also moderately correlated to acid binding capacity at 60, 120, and 180 minutes, accounting for 41 to 43% of the variation that was seen. So what's interesting to note here as well is that there were no correlations drawn between the mineral content of the limestone and the acid binding capacity. And then secondly, you'll see that all of these are moderate correlations, which tells us that there are more factors affecting the acid binding capacity of limestone than we currently know, which definitely warrants further investigation. The preliminary results for the in vitro part of this trial, when broilers were fed diets containing different phytase levels and different acid binding capacity values of the limestones, we see that there was no interaction noted. However, there was a main effect of the addition of limestone, where we can see that when no limestone is supplied in the diet, we end up with a significantly lower pH. However, there was no further mean separation between the limestones of different acid binding capacities. A main effect of phytase was also seen in the broilers, which is because the phytase is degrading phytate, releasing phosphate molecules, which obviously acts as a buffer in the avian digestive system. Similar to this, in the proventriculus pH, we only saw a main effect of the phytase addition, where once again 1,000 FTUs is resulting in a significantly higher pH value. And then for the effects that we saw for calcium and phosphorus digestibility, we are actually still currently awaiting analysis, but I do really hope to be having those results soon and presenting them to you. In conclusion, this definitely still is early days for us fully understanding at least, the acid binding capacity of limestone. But there is very promising preliminary results in showing us what are the factors affecting the acid binding capacity of limestone, as well as the effect that this has on the broiler gastrointestinal tract pH. In conclusion, to end off with, I'd just like to send a big thank you to AFMA for allowing me the opportunity to present today, as well as the knowledge, education, and opportunities that they're providing for other students in the industry. I'd also like to thank the University of Pretoria for the use of their facilities, as well as Dr. Nkukwana for her supervision during my studies. And finally, I'd like to thank both Neurolivestock Research and Communique for their technical and financial support during my studies, in particular to Terry Wiggle, Dr. Peter Plumstead, and of course, Carl Fenter. Without all the people that I mentioned on the slide behind me, I definitely wouldn't be here today. So big thank you to everyone.